The world of dentistry is rapidly evolving, and the shift from traditional to digital workflows can be daunting. At the Institute of Digital Dentistry, we're committed to demystifying this transition through our podcast, Digital Dentistry Decoded. We bring insights from global digital dentistry leaders directly to you, helping you stay ahead in this ever-changing field. Hey everyone, Dr. Ahmad Al-Hassiny here from the Institute of Digital Dentistry, and welcome to another exciting episode of Digital Dentistry Decoded. Today we're diving deep into the world of 3D printed restorations with a very special guest who's here to uncover the secrets behind his company's success in this revolutionary field. If you've been curious about the potential of 3D printing in restorative dentistry, you won't want to miss this. Ayush Bagla, who is the CEO of Ackuretta, joins us to share his company's groundbreaking strategy for cracking the code on 3D printing restorations. He'll be walking us through their innovative approach and sharing some game-changing insights that are sure to take your understanding of digital dentistry to the next level. So sit back, relax, and join me in welcoming Ayush Bagla to Digital Dentistry Decoded. Let's dive into the world of 3D printed restorations together and discover how Ackuretta is revolutionizing the industry, one printed tooth at a time. Hey everyone, welcome to another episode of Digital Dentistry Decoded. So in the past few episodes, we've spoken to some exciting CEOs and leaders of some big digital dentistry companies. And today is no different. It's a huge honor that we have Ayush here with us, who is the CEO of Ackuretta. How are you doing, Ayush? Thanks for joining me.
Hi, Dr. Ahmad Al-Hassiny. Great to be with you today and be on your show. And we've been a fan of IDD, and thank you for the great introduction. It's great to speak to you and to the dental audience.
The pleasure is mine, my friend. Now, a few of us who are into digital dentistry will know of Ackuretta, obviously a 3D printing company that is, I would say, up and coming for sure. I mean, you guys have made some pretty big waves with the Ackuretta Soul. But, before we get into all of that and what's happening and all the exciting stuff with the company, please just introduce yourself to the audience. How long have you been involved with Ackuretta? How long have you been involved with digital dentistry? All yours.
Okay. So it's a typical question I usually get because been in additive manufacturing almost 14 years now. So I started off in my education with additive manufacturing. I was in UK for my master's. So I have a background with design and manufacturing, especially for 3D print. And I started off with the metal technology. So I was doing SLM and I was printing gold jewelry back in 2012. So, people were like, wow, you're printing gold. 100 years ago, if you'd be doing that with a laser, people would jail you for sorcery. But my roots started off with the jewelry business. And from there, I saw this project may have limited applications in the jewelry industry. So we moved our focus from jewelry and said, okay, for metals, we can do polymers. And there we came across SLA technology and the ability to produce wax patterns for casting. And this was back in 2013. So I founded Ackuretta back then in 2013 with a focus on the jewelry market for wax castings. And we knew that dental and jewelry are similar because the scale and scope of the business in terms of, let's say, castings, it's both small parts, accurate parts, you need smooth surface finishes. So very similar in nature from that perspective, except the casting process was different. So started in 2013 with jewelry mainly, and we had a little bit of dental business. But what got exciting is two specific things. In 2014, 2015, the Invisalign patents expired. So as the Invisalign patents expired, there was a lot of interest for small and medium scale dental businesses to start producing models in high volume. So that started the initial wave of the desktop stereolithography machines, whether it was laser-based or DLP-based at the time, where they started gaining prominence. And we took this as a good opportunity and started focusing on this aspect of the market. And then in 2016, we saw that NextDent came out with a whole portfolio of resins. There was about 10 resins. And the whole concept of additive manufacturing is to produce end-use parts, which is completely customized, which could be made for, few dollars. This is the whole goal of additive manufacturing, be it in jewelry or in dental or in engineering or other applications. So with that in mind, we saw that, it's possible to produce temporary teeth. It's possible to do other applications. So back in 2014, we realized that Invisalign patents had expired. And after that, there was a high volume of models that people wanted to print, whether it was small or medium, usually dental labs, of course, some practices as well. And there was a huge uptake at that point and huge interest surrounding smaller stereolithography machines, either LCD type, DLP type, or the laser machines. With that in mind, we started focusing on this direction. And 2016, a lot of things changed because NextDent came out with a full portfolio of digital materials where you could produce a night guard, a temporary crown, a denture, and certain other dental applications for end-use products. We're not talking about patterns and tools anymore, but real end-use products. And that really inspired us that you could produce these things at few dollars a piece within an hour. And that's real direct manufacturing. And because we come from the 3D printing world, we realized that the real future of additive manufacturing is not to do prototypes and not to do tooling, but it's to create end-use, high-quality, customized parts with, let's say, unique geometry. And dental is a very good product market fit for additive manufacturing because there's no two teeth on the earth that are the same. So if you have a degree of customization required in every product that you make, this is the most cost-effective technology to do so. And hence, additive manufacturing is called the fourth industrial revolution. So yes, I would say that we took a hard pivot after seeing what NextDent did and seeing the innovations on the material side back in 2016, 2017. And it's been 6 years since, and we have a business in almost 80 countries already. So we've got quite a large coverage in these regions, and we keep growing our business and team every year.
That's incredible, man. Now, look, thanks so much for sharing that. That's like a whole 3D printing lesson for anyone who's listening about the history about 3D printing in dentistry. Super interesting. And it's the whole jewelry thing is something that you hear time and time again. And I was going to ask, why do so many printers go from jewelry to dental? And you kind of answered it, which is really cool. And so you would say now most of your business is dental? It was like a complete pivot?
Yeah, I would say north of 95%. We still have certain businesses in other verticals.
Wow. Awesome. Well, obviously dental 3D printing is the place to be, and definitely from what I'm hearing on the ground and through, teaching dentists and technicians and whatnot, probably the biggest hype topic in dentistry for a long time. Given you pivoted quite early, you would have seen the whole industry change. You probably would have developed your business as 3D printing was developing in dentistry in the first place. I mean, what are some of the things that you've seen radically change in dental 3D printing? Apart from, of course, the acceptance, because you mentioned 2016, you guys probably first got started. And back then, I don't know anyone who was talking about 3D printing that much. There was 2019, I remember IDS, there was a number of 3D printers, but it seemed to have really exploded in the past 2-3 years.
Yes, that's quite accurate, I would say. So the market was very different 8 years ago. And some of the key differences were that the printing technology was never developed for dentistry specifically. All the printer companies were for engineering, and they used to cater to like 4 or 5 applications. So there's certain companies who still market themselves in the same way, where they make a generic printer and a generic solution and then say, okay, here's a concept, we're selling you a concept and you can use it for all these applications. So that's what was being, let's say, sold or being available in the market at that point. However, when people started going into the dental market, they realized that the software needs to change. It needs a change with exocad and 3Shape. You need the integration done. You need the material profiles of all these applications, very good post-processing systems, the biocompliance to meet dental standards. So all this was very essential for companies to get it together. And as the dental market grew, people started making these dental-specific products that you see. They started changing the machine colors more to white and clinical looks. and the machines became easier to use. The technology became simpler and more user friendly. And back then, 2016 to 2020, I would say the whole technology was focused on the lab, and they were more like techie machines where you had more flexibility, more freedom. But the lab was a primary adopter of this technology. Not to say that now the lab is not the primary adopter, which it is, but ever since 2021, we're clearly seeing that there's a large number of clinics and a large number of digital dentistry adoption within the clinical space. So the machines that are designed for the clinics have to be significantly easier to use, smaller in terms of form factor, and have the same capabilities and power as the larger industrial units. So quite a challenge to do those. And we are one of the companies that have been developing in that direction. So yes, there's a different market with lab and clinic. And I would say in the last 8 years, that's a big evolution that we've seen.
And I have to agree, especially on the clinic side, just listening to dentists and going through Facebook forums and whatnot, and Instagram and all the different social media. So many clinicians are interested in 3D printing. It's quite crazy to me, to be honest, because it's far higher of a number than we're ever interested in milling in-house, for example. And I think it's obvious why. You said it so eloquently. It's the fact that a 3D printer is the most cost-effective way of producing the intricate and highly customized prosthetics for patients. And definitely I feel like the price is really driving this compared to 3D milling.
Oh, 100%. There's a rule in the startup industry of 10x cheaper and or 3x better. And I can break that down on an application basis. Today, 3D printing is significantly cheaper. I won't say 10x compared to a milling machine. But in terms of the performance, it's so much better to get a splint out of a 3D printer than it is in a mill. However, when you look at the crown or a denture, the 3D printer may have certain advantages, but in an overall, the advantages of the mill may be more. So you haven't seen a disruption in that segment of the market.
100%, and totally agree. I mean, I think now 3D printing splints has basically become mainstream. You know, a lot of labs are doing it, especially with the advent of materials like key splint soft that really pushed everything into the mainstream. And I think that's what's so exciting about 3D printing is it's really a materials game now. And we'll get into that with like a pack dent soon in our discussions, no doubt. But it really is who can crack the code of a great 3D printable resin. I mean, once you do that, I think, especially in some of those key aspects that dentists are really asking for, like crowns, especially long-term restoration, that's really going to change things. Right now, I wouldn't say it's niche because it doesn't feel like it's niche. It's quite early adopter / even beyond that, but still not as many clinicians are that convinced about all the benefits of 3D printing.
Well said. I do believe that the industry evolved in multiple phases. The first phase was that people were doing orthodontics because 100% of the aligners and retainers that were produced requires a 3D printer. And the second phase was general dentistry, where you started seeing like splints, night guards, surgical devices, these kind of things being produced by the printer. And the third phase is around the restorative piece. So restorative dentistry is, we hope it's the today. However, like you said, the clinicians, even labs are not as convinced as we would like them to be to make the transition. However, I do believe in the next 3 years, we will see that becoming more mainstream, simply because the solutions are being built around it. The AI CAD software, the AI CAM software, the material chemistry is improving for a mass market level. And the stain, the glaze, the bond, and the cement, all of those innovations are helping create the complete workflow. And that's what's currently lacking in the last 2-3 years of innovations with the crowns. Because we've observed whenever we talk to a client or we talk to a KOL or we visit a training course, people are like, okay, you can print a crown and then what? So there's all those processes after that they don't have enough knowledge and information about, and there's no workflow for them to follow and respect. So that's what is creating, let's say, a lack of confidence on the technology yet. They're saying it's nice, it's experimental, but they want to wait and watch.
And it's probably like you said, because a lot of these technologies were made for other industries. And so when it's made for jewelers and then is kind of adopted by dentistry, even though it becomes a big segment of their business, there hasn't been that development cycle for the bonds or the staining kits. A lot of dentists to this day are using composite staining kit, like, OptiGlaze and things like that for their printables. We don't really have yet a complete solution. We do have some good systems out there, I'm sure you're aware of them, that are pushing same-day printed crowns. In terms of a complete A to Z solution, including stain kits, including bonding, including cementation, to me, a lot of this 3D printing, especially for restorations, I think splints is done and dusted. Like you said, models is done. Implant guides are done. But for restorations, it still seems to be almost guesswork, or you're relying on some key opinion leaders to tell you how they do it. There doesn't seem to be established protocols. Would you agree?
Most certainly, the established protocols, we are looking at anywhere between 12 to 36 months to get these more mainstreams. And there's still blockages, whether it's on the CAD, the knowledge, the education, and just the ease of use of the whole process. So it's not quite where it needs to be just yet.
So before we jump into some of the cool things that your company has been up to, because I know you guys have been super busy, what do you think? I mean, let's just get this out of the way. I've talked to a lot of different heads of companies about printing versus milling. I mean, I hate to say versus milling because I think the technologies complement each other. You have a keen eye on all the background chemistry and development that's going on. Do you think we're going to get to the point where we 3D print a crown and it's seen as an acceptable long-term replacement for something like lithium disilicate EMAX or zirconia? Or is it still as it is now, even though a lot of people are trying to push it? To me, it just seems like an indirect composite replacement. Do you see the material development that are happening in the background that you think we're going to crack that and there'll be a paradigm shift in dentistry?
Very good question. I see that if you want to change technology from an existing technology to a new technology, you need to be cheaper, faster, or better, or at least 2 out of 3. And it needs to be significantly better for people to make that migration. And with 3D printing, let's say, versus milling, just for the moment, there's 2 approaches on the material chemistry. The first approach is a certain amount of filler and resin, which is flowable, and you can use, let's say, a generic 3D printer from any of the popular brands. Or the second approach is you have a customized machine and a material solution with very high filler where you can print something like zirconia. So the limitation that we've so far seen is that if you tell a customer to pay $100,000 or above to produce zirconia using 3D print versus you could buy a roll-in milling machine for a third or a fourth of the price, and it's an established protocol, very hard in today's times to convince that kind of buyer to transition to 3D printing, even though it may have some geometric advantages in the process. However, the advantages, don't outweigh the price tag. So that's where I see it would be hard for a 3D printer to beat a mill when it comes to those high-end materials in terms of like a zirconia or an EMAC. But when you come to the economy materials like PMMA or, like you said, the lithium disilicate, there, if you can use a generic 3D printer, you could buy one of those for, let's say, less than $10,000 for sake of discussion. And there's plenty of options out there. That's significantly lower than the cost of milling, and you could print a crown in under 30 minutes. And there we can reach a theoretical limit of a biaxial flex strength of maybe up to 250 MPa. Anything above that would be very difficult to do on the theoretical limit of the chemistry. So my forecast is in the next 2 years, you will see materials reaching that sort of mechanical properties, and 3D printing could take some portion of the economy milling market, not more than 20%. My forecast would be anywhere between 5 and 10% in the first 2 years.
How interesting. Some great insights there for everyone listening. 250 megapascals, it's about half of Emax. And who knows, is that enough? I mean, that's more than our traditional like impress and felspathic ceramics. So yeah, time will tell, I guess, how much market share it really does take. I guess moving on from materials, because everyone loves to talk about 3D printed crowns, etc. I'd love to hear about what your company has been up to and some of the insight and cool stuff that Ackuretta is doing. I'm sure a lot of people are very interested. Obviously, you've released the Dentique, you've released the Soul, and correct me if I'm wrong, I think the Soul was probably the really breakthrough product for the company in terms of dental. It really seems to be quite a popular 3D printer, especially for those who are looking for a more economical option. Would you say that was the main product that helped you break into dental?
Yes, I would say that helped us establish a name for quality and, let's say, reliability in the market. The previous systems that we had were not as mature as we needed to be to satisfy the dental market needs. And yes, with the Soul, we've managed to get somewhere in the global scale.
So Soul is a LCD printer. And I think we've moved away from thinking that all LCDs are the same because they really aren't. But a lot of people still think LCD is kind of an inferior product to DLP or SLA. What do you have to say about that? A lot of people do seem to have that kind of thought around LCD printers. And I personally believe it's because of the first few LCD printers that came on the market that almost gave it a bad name. Is that something that you've heard or experienced through dentists?
Oh, certainly. The thing is that there's a majority of LCD printers that they've been built at a price for a different consumer application group that's not very demanding. And, you pay for what you get at the end of the day. So those machines were never designed for an industrial or a commercial application. However, they are being used for one. And when we've created a system for those commercial or industrial applications, the price of the system significantly goes up, and also the quality standards as well. So people have this notion in their head and experience with the commercial printers that they attribute a certain value and a certain stigma to the technology. So that stuck with a lot of people, and therefore they give value to, let's say, a DLP as more expensive and something a bit more robust. But it's not necessarily the case because our company was building DLPs since 2015. So we ourselves transitioned our technology from DLP to LCD because we believe our LCD printers can do more in most aspects compared to DLP.
Do you mind elaborating on some of those aspects, if that's okay? I'm sure some people, for the layman, of course, a lot of dentists are not engineers, and we don't quite get into the details like engineers, but I'm sure people will be curious what your experience has been.
Absolutely. So with DLPs, we noticed a lot of different aspects, whether it's the supply chain of the component is expensive. And if we want to produce a DLP machines, they got to be typically heavy. You will never see a DLP machine which is anything lower than 10 kilos unless you're talking about the DIY ones. But a professional machine, there is a ratio between the light engine weight to the product weight. So as it gets heavier, it needs to be more expensive to produce. And the risk with the DLP is that if you put it on its side, basically it loses its calibration to some extent. And you'll never get accurate results after that. So I would say the cost, some of the disadvantages that you'd face. But the DLP, on the other hand, you can use 385 nanometer LEDs. So for people who like to print transparent parts, whether it's a surgical guide, a splint, or something in engineering, there's an advantage on that aspect. The second advantage is a DLP can produce more power than the LCD systems in terms of power density. So that depends on which material chemistry one is using and which company's resin one would like to print. There is certain specific resins that require such high power or, let's say, the minimum curing performance. So those are the two advantages of the DLP compared to the LCD. However, when you come to the LCD side, the systems can be built in a much more cost-effective basis. They are more rugged, like we've transported them, an overhead luggage in the plane across different countries for trainings and for workshops and stuff like that. And the machines, they don't break and nothing goes wrong with them. very easy to service LCD machines. They produce very good quality of surface finish on the results. And we've learned how to make them accurate and reliable. To add to that, as you know, in your house, are you using an LCD TV or are you using a DLP projector?
Yeah, yeah, exactly. I think everyone who would be listening is using LCD, right?
Yeah, and that's the thing, that they moved from the projector to the LCD as the next evolution. So with LCD, you can scale the size significantly easier. And as you know, the resolution of the screens are far higher than the DLP. So the pixel size is also smaller and the surface is therefore better. With DLP, unfortunately, there's an inverse relationship between the size and the power. So if we have a very large image or a very large curing area, or let's say a very large print area, then the power density of that machine will be significantly lower unless somebody spends a lot of money to make a higher power LED and a system around that. But at that point, you're looking at over $15,000-$20,000 just for the system. And the number of people who want to buy such expensive technology in its early stage in clinical dentistry or even in lab dentistry, it's going to be limited.
That's really interesting. Is that part of the reason why a lot of DLP printers tend to have smaller build platforms, I wonder?
That's exactly the reason why.
Yeah, interesting. It's like a light bulb moment. I mean, that makes a lot of sense. Once again, you were saying like the bigger, essentially the platform or let's say the curing area, the much higher power you would need for a DLP, or let's say the less power output for the same machine. Is that kind of what you were saying?
Yes. If you have a DLP, then with a larger surface area, let's say a larger print area, you would need more power. And if the LED can't do that or the system is not designed for that, then the curing performance would just become slower. And with a larger area, as we know, the printing time is a bit more, whichever machine that you use. So it becomes a lot slower, and dental parts are quite small. The largest part you would print in dentistry may be like, let's say a dental tray or, one of those larger models. So if you're not printing large engineering parts, like one part is like 200 mm by 200 mm, you're printing something which is 80 mm by 80 mm. So you don't need a large area, but you do need one if you're producing high volume. So users have a choice to either buy a bigger printer or buy a couple of smaller ones.
Really cool. Really interesting. I do wonder, there's this big fear about having to replace LCD screens. It kind of tainted the LCD 3D printer market in dentistry, where a lot of people are talking about having to replace the screen or the plate or whatever, the LCD little thing where it cures. Is that just something that's not the case and shouldn't really be a worry for modern dental LCD printers?
I think it's less of a worry, because I'll give you a flip side of that, as we are both in the DLP and the LCD business. So a lot of users end up damaging the machine by being careless, or let's say the resin spills out of the vat and it cures on the LCD. They say the LCD got damaged, but the root cause was actually a user error or inexperience by the user rather than the technology failure. So the previous generation of LCDs back from, let's say, 2018 to 2021, those were more the RGB type of LCDs, which had like red, green, and blue illumination. And those had a much shorter lifespan. However, after 2021, the technology started moving to monochrome or black and white LCD screens, which are far more durable. I'm talking about 5-10 times more durable compared to the RGB screen in terms of life. So with that in mind, over the last few years, we are very safely able to produce parts consistently and reliably using LCD printers. And yes, you will find certain panels that are lemons, for the lack of a better word, but the replacement process is less than 15 minutes. If you compare that to a DLP system and you put resin onto your projector, or the projector has gone down for any reason, there is no way the user could fix that. There is no way most distributors of such products could fix it. It would need to go back to the manufacturer for replacement and recalibration. So it's a very serious level of repair, and the downtime required for this operation is, I would be surprised if a manufacturer could turn that around in a month. So it's a pro and con, right?
Yeah, yeah. I totally didn't think of that, to be honest. Like, on one hand, yeah, you may need to replace it, but on the other hand, you can replace it if you ever need to.
Absolutely. And when you buy a $10,000, $20,000, $30,000 DLP machine, it's capital equipment. You may not have a spare printer. So what happens to the production and the business depending on that piece of hardware for that duration of time? So it would drive the user to potentially buy a second unit, and then that's double the capex cost. So where does the buck stop? And this is where the LCD printers have a significant advantage, where a user could easily afford one, two, three of them for the same price as a DLP system. And the panel goes down, it's 15 minutes of change. And it's pretty easy to do that by watching a YouTube video.
So what about in terms of like accuracy? And I know accuracy with 3D printers is a bit of a complex topic, but is there a major difference in terms of the dental uses between DLP and LCD?
In terms of the accuracy, we would take a general standard and say if you can get 80, 90% of the part within a plus minus range of 100 micron, you satisfy most, if not all, dental appliances. This is the funny thing, and this is a misnomer that maybe I can share some knowledge about. The accuracy of the 3D printed part is related to not only the 3D printer, but the post-curing. And it is more in the post-curing than the 3D printer. And the reason is only 20% of the curing that's taking place in the process is happening on the 3D printer, while 80% of the curing is happening at the post-processor, at the post-curing station. So by that metric, the UV box and the post-cure station is basically more important than the 3D printer when it comes to the subject of accuracy, and how the manufacturers are creating systems to ensure that the accuracy of the whole process gives a consistent result. If anybody is using DLP or LCD, I would say the more important thing is that they use a validated system which has all this dialed in, so they don't need to do the guesswork.
That's pretty incredible, man. I knew that the post-processing was important, but 20 to 80%, that's crazy. I mean, and I'm sure a lot of people are thinking, wow, I need to go back into my office or lab and make sure I'm using the right settings, because right now there's not a ton of regulation on any of this stuff. And you do hear of the horror stories of people using nail polish curing boxes to cure these things. I mean, I've never seen it, but it is kind of a wild west out there in terms of post-processing. And I think you bring up a great point in that, especially clinicians who are moving more and more of the stuff in-house, this in-house manufacturing, they really need to take careful measures to make sure the entire process is done properly.
Most certainly, and I'll tell you a quick point on post-processing. Certain users believe that if you can over-cure a resin, it's going to be safer than under-curing. However, we've done tests to prove that it's quite the opposite. The over-curing results in more toxicity than under-curing does. And if you just read the MSDS on any of the resins, you will find that every resin is carcinogenic in nature. So it's really playing with fire if somebody is not respecting the post-processing protocol.
So many pearls of wisdom there, guys. There you had it. If anyone knows about post-processing resins, it's Ayush, and he tells you, cure them properly, make sure you're taking it seriously, and make sure you don't over-cure. I mean, I'm probably guilty of that too. You always think, over-curing is better than under-curing, but there you go. I am curious. I mean, apart from just talking about all the chemistry, which is super interesting, but I'm mindful of time and I really want to get into some of the cool stuff that Ackuretta has been up to. Do you have any stuff, some exciting things the company is working on, or any new launches that are coming up that you can share?
Well, in a nutshell, I can say 2024 is going to be a big year for us. There's a lot of things that have been in the pipe with Ackuretta for a couple of years. So we went through a very large development cycle after the Soul, and this is the next phase for our business. So we started off focusing on the clinical user with the Soul. Of course, a lot of the users are labs. And we see that people today are looking, like I said, in the third phase of evolution of the dental business, where they move from orthodontics to general dentistry and now to restorative. So the solutions that we are coming out with is going to be geared more towards the restorative market. We see that as a huge market because 50 million crowns a year are placed there's almost 10 million people in the world who require full dentures. So with that in mind, we're looking to make machine material software solutions to cater to those specific market needs, whether it's in the lab or in the clinic.
Is there any particular products that you're comfortable sharing with us today, or is it wait and see for the big year?
So one thing we have would be a nitrogen generator, which is very much required for restorative materials. We observe that the mechanical properties of materials, depending on the material chemistry, are enhancing with the use of nitrogen. And in different countries, nitrogen tanks are regulated. So there's certain challenges that users are facing and insurance risks to add an extra tank into their practice or into their lab. So the nitrogen generator is one such very interesting innovation that we're working on. There's a new line of materials coming to focus on the restorative end of the business. With our Alpha AI software, we are launching a few modules. These modules will be focused on improving the ease of producing these restorative pieces as well. And we will be looking at building a larger printing solutions for customers who just have larger printing needs.
Awesome. Very exciting about the nitrogen generator for sure. I mean, I agree. I think a lot of different printing companies are trying to figure out the solution of oxygen inhibition layer. And I had a prime print in my office. Obviously, you need a nitrogen tank. And frankly, the nitrogen tanks are annoying. I don't know about other places in the world, but in New Zealand, you have to go through a special company to get them. They're quite large. It looks like you have a torpedo in your office. It's a big tank. And it just sits there. And it's kind of annoying. It's this additional factor you have to think about. And a nitrogen generator from the air would be awesome. And I know the company's been trying to sort that out. You guys were going to release the generator, I think, a couple of weeks ago, a month ago, but it didn't pan out. What happened anyway? Was it just not ready for market?
I think we had to take in some more mass production considerations before we roll out such a product, as it's our first attempt into the nitrogen business, which is very different from creating a UV box or a printing system. So we just needed to dot some I's and slash some T's, and you'll see that early next year.
So it's definitely coming. It's not like something like the, what's that mill from Ivoclar that, I don't know if you're familiar with the milling business, but Ivoclar was going to release a mill. They had a product at all the shows, and then sadly, I mean, I love the company, it got pulled down. So it's definitely not one of those solutions, is it?
No, definitely not. And we've sent a few for beta testing, and the results have been promising. And the in-house results that we've seen is very promising as well. And we're getting a lot of positive market feedback where people are like, it's not we need this, we want this, and we really need to have this. There's no other solution out there in the market. So where we are at the moment to the finish line, we are not far away. We've already passed the prototype stage and even the beta model stage. So we just need to, like I said, dot some I's and cross some T's, and we're certainly going to get to the finish line shortly.
That's super exciting, man. And for those who don't really get what we're talking about, a nitrogen generator, you might be wondering what's that for. In short, it's basically oxygen inhibition layer. When we're curing these printables, we want to do something to get rid of all the oxygen in the environment so that you get a full cure and ensure biocompatibility. Currently, there's only really 3 ways to do it, unless, Ayush, please correct me if I'm wrong. You either put things in glycerin or any other medium. I know some people are using water, but glycerin, like KY jelly, is quite popular. Basically, in a little tub, your printables go in a tub of glycerin and then you cure them. There's also a vacuum. Some printing companies make their curing units have a vacuum, so it basically sucks out all the oxygen and then cures. And of course, quite a unique innovation by Ackuretta is a nitrogen generator. So this nitrogen generator, basically, I mean, the air is full of nitrogen. It will pull it from the air and then pump it into the curing unit, so to push out all the oxygen, and then you have an oxygen-free environment to cure. Is that a good summary of the technology they use?
That's a very good summary, Doctor. The only thing I could say is that we've tried all these methods. The others work, of course, but the nitrogen has, let's say, the highest performance gain. and is also the most expensive to do. But we decided to go with that, as with restorative dentistry and the end use products that we're trying to manufacture, people are looking at that higher bar of quality standard relative to something that's just a little better than not using one of these techniques that you mentioned.
Yeah, and I guess that's what's so exciting about digital dentistry, Ayush, is that, like, for me as an end user, I'm still a full-time dentist at the end of the day. And I freaking love dentistry. I love being in the clinic. I love working on patients, providing my patients with solutions. It's what gets me out of bed. And what's exciting for me is that all these different companies are trying to innovate and provide solutions. Like, nitrogen generator. I don't know about other industries because I focus on dentistry, but I've never heard of that before. And it's just super cool that you guys have invented that.
Yes, not very common, but we've seen this in 3D printing in the SLS business. So they use it over there to control the environment for different reasons. But yes, in dental, people have been using a nitrogen tank on certain other post-curing products. However, the generator, it takes the game to a very different level. And we realize that there's so many reasons why people want it. And it's going to be a product of the future where we see that system could continue becoming like a mainstream product for the next 15, 20 years with just minimal requirements of innovation.
Yeah, and I think the cool thing is that would be a standout product for the entire company. Like, a lot of companies are making 3D printers. A lot of companies are innovating in some way in the resin side or the printer side or the hardware, but very few are really strongly putting their efforts in this post-processing and curing side especially. And if what you say is true, out of the whole process, 80% is all post-processing. That's the 80% of the importance is post-processing. You might be onto something. And to me, it's quite interesting because I don't know that many dentists that do all the glycerin stuff, to be honest. I know it's said and people talk about it in Facebook groups, and it's always the 1% that are the loudest in digital dentistry. But is it important, as they say? Do you think it's vital that we control this oxygen inhibition layer? What would you say for those people who are not doing anything currently? Should they, their curing unit may not even have any features like vacuum or nitrogen gas. Should they be immediately using glycerin?
I believe it depends on the output that they're trying to achieve. So if you're doing models, surgical guides, class 1 products like a try-in, it's not as important. However, when you come to the class 2 applications, which are end-use products like temporaries, permanents, dentures, splints, for these applications, there's a tangible advantage. And for the splints, for example, you get a very much more transparent finish. I won't say it's transparent, so translucent finish. And with the denture and the crowns or bridges or teeth, you get significantly enhanced mechanical properties. So I would say 10-20% easy on that. And that's exactly the reason why people are today skeptical about the performance of dentures or crowns as a permanent application. So anything that could help alleviate the performance of that for users who are desiring to do those applications chair-side or lab-side, I would advise nitrogen generator. For the other applications, it's a nice to have. I won't say it's a must.
Super interesting. I'm personally super looking forward to this nitrogen generator, and it's quite a small unit too. It's kind of amazing how you've squeezed so much technology in such a small unit. And I feel like, a lot of dental clinics, they don't really have that much space to begin with. So hopefully a really fit for purpose device. I guess to end the podcast, what are some of the things that you think will change in digital dentistry in the next 5 years? Is there any insights or, even as an open mic, is there anything that you want to discuss that's happening in digital dentistry that's interesting, or anything with the company? Please go ahead.
Sure. That's a very good question. And, before being a company owner or being a part of Ackuretta, I'm a technology enthusiast. So I'm keen to see, right? Like, where does this go and how is it going to change the lives of the people around us? Because that's the main reason why we are all aligned to this vision. So a couple of things that we are definitely sure about that's trending in a certain direction would be, one is the buzzword AI. So where is AI being used today in dentistry? Actually, in quite a lot of places. The common one that a lot of us may know about is in the design. So AI does the heavy lifting on the design and then, maybe does the whole work, but is definitely going to do the heavy lifting and reduce the amount of effort and skills required to do the design process. And that's one of the biggest bottlenecks of digital dentistry today. So if we solve for the design, the next step would be the materials, and material chemistry is going to improve. However, the chemistry can only improve the hardware. So if the chemistry has to improve, the hardware has to improve with the chemistry. That means a better printer or different functions in the printer. It means a better post-process, things like nitrogen to the post-process. So that's going to help getting a better clinical outcome from the parts. And the whole process of digital dentistry is going to get far more streamlined. Whether it's milling, whether it's printing, it's just going to get streamlined. It may get more cost effective and therefore accessible to a larger market. And the key at the end of the day would be the education that, hey, this is now more accessible to everybody. It's more easy to use for everybody. And it's something where there's enough use cases and enough proof that this is the right investment for clinicians or labs to make to grow their practices.
I have to agree, man. AI, definitely, like you say, a buzzword, a little bit of a hype word, I think, but no doubt is going to impact dentistry significantly in the next 5 years. Still, the biggest barrier, I think, for digital dentistry, especially those who are trying to produce something in-house, and I'm talking to the clinicians, is the CAD space. I mean, a lot of people still don't want to design anything. And if AI can get to the point where it does the majority of that, I think you'll get a lot more clinicians adopting things like 3D printers in-house.
Absolutely. And we've noticed this even in developing countries. There is a big requirement for economy restorations. However, the CAD skills are not quite there. So the AI would help a lot of those countries where there's a high population to get into 3D printing and basically have more high quality clinical outcomes and serve more patients.
So do you think in terms of the hardware, you mentioned the hardware improving, do you think we still have, let's say, I wouldn't say a long way to go, but do you think there's still on the roadmap many improvements ahead? Because I feel like with milling, it's sort of plateaued in a way. It felt like milling just can't get any better. All we've seen with milling in the past, let's say 5 to 10 years, is better materials, no doubt, but the milling machines themselves, they've kind of been the same for a very long time. Yes, we got faster zirconia milling, but apart from that, I mean, they really haven't improved that much. They've kind of plateaued in terms of technology. Do you think with printing, we've reached that kind of hardware tech, or there's still a lot more to come?
I would say that we haven't plateaued, but the upside that we've seen in the last 8-10 years, which has shifted, like, let's say, from laser-based SLA printing to DLP-based 3D printing and now to LCD, we don't see any other imaging technology after LCD where you can have, like, let's say, a big needle mover in terms of the hardware. So the hardware will still see some growth in terms of performance, user experience, reliability, but the jump is not going to be that 1 to 10 jump. It's just going to be increments from here on.
Super interesting insight. Look, Ayush, once again, I just want to thank you for your time. I mean, I think everyone listening, me included, got a lot out of today, a lot out of your insights and all the pearls of wisdom, all the little golden nuggets that you've mentioned today about the industry, and once again, how important post-processing is. I'll wrap up this episode today. Thank you so much for your time, Ayush, and I hope we chat soon again.
Absolutely, Doctor. Thank you so much for having me here with the IDD podcast, and it's a pleasure for me to share my knowledge from a technology standpoint in a dental industry. Never thought I'd be here, but it's a pleasure to be here to educate and enlighten the audience.
The pleasure is ours. And again, for everyone who's listening, it's going to be a massive year for Ackuretta. It sounds like there's a lot in the pipeline. As he mentioned, new materials, new printers, new complete workflows. So without a doubt, an upcoming company in 3D printing and in digital dentistry. So one to keep an eye out for. Thanks everyone for listening, and we will see you in the next episode of Digital Dentistry Decoded. And that's it for this episode of Digital Dentistry Decoded. Thanks so much for listening, and a big thank you to Ayush Bagla for joining me today. If you've enjoyed the show, remember to rate and review us wherever you get your podcasts. Be sure to sign up for our free digital dentistry courses at instituteofdigitaldentistry.com and follow us in your favorite podcast app so you can listen to our next episode. In our next episode, we're thrilled to dive into the exciting world of AI-powered smile design with a very special guest, Ralph George, the innovative mind behind SmileFi. Join us as we explore how artificial intelligence is transforming cosmetic dentistry, automating aesthetics, and revolutionizing the way we approach smile design. Ralph will share his insights on the future of digital dentistry and how SmileFi's cutting-edge technology is empowering dentists to create stunning smiles with unprecedented precision and efficiency. Whether you're a seasoned cosmetic dentist or just starting your digital dentistry journey, you won't want to miss this fascinating conversation. Discover how AI is redefining what's possible in our field and learn how you can harness its power to elevate your practice and stay ahead in this rapidly evolving landscape. Tune in to our next episode of Digital Dentistry Decoded, where we'll be decoding the future of AI-driven smile design with the one and only Ralph George. Until then, keep embracing the digital revolution. The digital revolution continues, and we're here to keep you at the forefront. You've been listening to Digital Dentistry Decoded. I'm Dr. Ahmad Al-Hassiny, helping you stay ahead of the curve in this dynamic world of digital dentistry. Thanks for listening.